The properties of integration are characteristics that help us break down integration operations and simplify them. For example, if we see a constant multiplied by a function that we want to integrate, we take the constant outside and integrate the f of x. Then we take the result and multiply it by the same constant. Example, if we have 3 times x that we want to integrate, we can take the 3 outside and integrate the x. The result comes out here. Then we take the 3 and multiply it by the result. We multiply it by the result here, and it comes out to 3x squared over 2. Then we take the 3 and multiply it by the c as well, but 3 times the constant c will come out as the constant c itself, because we don't know its value, but we know it's a constant. 1/2 times x, same thing, we take the half outside and integrate the x, then we take the half and multiply it by the result. 2 times an exponential function, here we have e to the power of x, we take the 2 outside and integrate the exponential function as we saw in the previous lesson, then multiply 2 by the result. Same thing here, but the integral of the exponential function here will put ln 2 because it's ln of the base, same as we saw in the previous lesson. Then we multiply the 3 by the result. 3 times c will equal the constant c itself. When we look at the integral, or at this property, from the standpoint of multiplying it by a constant, we look at it from the standpoint of it being the area between the function's curve and the x-axis. So multiplying by a constant either enlarges the area, or shrinks it if it's between 0 and 1, or reverses it if it's negative. That's why this property. When we have the addition of 2 functions, or their subtraction, that we want to integrate, we can take the first function and integrate it, and take the second function and integrate it, and add the results or subtract them according to the sign. A very direct property, meaning x plus 1, we integrate the x, then integrate the 1, then add the results. Of course, c plus c, or a constant times c, will give us the constant c unchanged. X minus 1, same thing, we take the x and integrate it, the 1 and integrate it, then add the results. If we look at this property from the standpoint of areas, then for example, when we add 2 functions, we add the 2 areas. The first function like this, the second function like this, when we add the 2 areas, it's as if we integrate them or add their integrals. So the results come out, the area, all of this. Dividing the interval, this is a simple property that the integral from 0 to 5, for example, is the same as the integral of the function from 0 to 3 plus 3 to 5. When we imagine the areas, it becomes clear that the integral from 0 to 5 is the same as the integral from 0 to 3 plus from 3 to 5, which is this area plus this area. And finally, an important warning. The multiplication rule does not work in this same way. Meaning, if we see a function multiplied by a function that we want to integrate, it's wrong to integrate the first function, then integrate the second function, and multiply the results by each other. Multiplying 2 functions has another property and a different method, which we'll study in the coming lessons.